Good evening, millennials. Today, we'll be looking at another easy problem often asked in FAANG interviews in the very initial stages. So, let's look at this problem, which is the 350th problem in the LeetCode website. The problem, intersection of two arrays, part 2. If you want to see the first one, just have a look at it so that you'll understand our code better. Please view our previous video. So, let's read this question. Given two integer arrays nums1 and nums2, return an array of their intersection. Each element in the result must appear as many times as it shows in both the arrays, and you may return the result in any order. Okay, seems very simple. So let's read at example 1. Nums1 is 1, 2, 2 and 1, and nums2 is 2 and 2. So as you can see, the intersection is 2 and 2, so we get 2 and 2. And you can return this in any order. So nums1 in the second example is 4, 9 and 5, and nums2 in the second example is 9, 4, 9, 8 and 4. So on output you get 4 and 9. Also 9 and 4 is accepted. So let's look at the constraints. So nums.length must lie between 1 and 1000. Of both the arrays lie between 1 and 1000. So as you can see, you can write an n-square algorithm for this, but we can try to make it simpler because these are not accepted in an interview. Also, each element of the array is between 0 and 1000. So let's look at some follow-ups and try to discuss those. So what if the given array is already sorted? How would you optimize your algorithm? What if nums1 size is small compared to num2 size? Which algorithm is better? What if elements of num2 are stored on disk and the memory is limited such that you cannot load all the elements into the memory at once? So let's try to answer these questions after thinking of our approach. So the basic approach or the brute force approach you can think is just check for each element in the other array and just put it into one vector, but that will be very costly in order of n square or n cube. So we can use another method of using a map and counting each element, as you want only the count of both the elements. So you can use one map for nums1, another map for nums2, and then find the minimum of those count for each of these intersecting elements, and then just put it in a new vector. So let me just do that. So let me have a final vector int answer that I will return, and so I will return that at the end of the function call. So in between I will have two maps. So this is map 1 for nums1 and map 2 for nums2. So I will just populate the maps. So the key will be the element and the value will be the frequency of the element. So I just iterate through the nums array and I will do num plus plus. I'm just increasing the count of the number. Similarly, when I iterate through the second array, I just increase the count in the map. So I just increase the count. Now I need to either traverse the first or the second array. Now you can see the follow-up question number 2. What if nums1 size is lesser compared to nums2 size? So depending on that, you can take a call whether you have to traverse the first array or the second array. Or I think it'll be better if you can traverse the maps. So let me just do that. For auto element colon mm1. So when I'm traversing the map, if I'm traversing the first map, so I have to find whether that element exists in the second map. So if mm2 dot find of element dot first, remember element will be a key value pair and you have to find whether the value exists. So not equal to mm2.n, which means it exists. Then inside the if condition, if the element exists, you need to find the minimum count in both the arrays so that the intersection will be the minimum of both. So assume if there are two 4s and only one 4, you need only one 4 in the answer. So the count will be minimum of element dot second and mm2 of element dot first. So you find the frequency in both the maps and then you then you take the minimum of both. Then while the count is there, you just push it to our final answer array. So answer dot push underscore back of element dot first, because you need to push the first element. You need to push the element itself and not the frequency. So I just let me just try run the code. So I create a map for both the elements, and then I iterate either of the maps, and I find whether the element exists. If it exists, I find the minimum count in both of them, and then I push it back to our answer array. So I think this should work. Yeah, as you can see, it works for this case. So let's just submit it. I've done it long ago in the past. Yeah, this is faster than 63% of the solutions. So coming to this follow up, so there's another method where you can just sort both the arrays. Since this is order of n, you can either do it in order in a better approach without using maps and extra memory by sorting it and then having 2 pointers for both the arrays. So if your array is already sorted, you don't need to again sort it, and that will be a better of n's order of n algorithm in that case, if you can use a 2 pointer approach. So coming to the second follow up, what if nums1 size is small compared to nums2 size? Yeah, in that case, I think it's better when we go to the 2 pointer algorithm, because you'll just be traversing till the end of the shorter one, and we don't need to fully traverse the longer array. And for the third one, it's mostly asked in system design question interviews. What if elements are num2 are stored on disk and the memory is limited such that you cannot load all the elements into the memory at once? So this is called bulk importing. So when there are cases like this in production, what we usually do is we just load it in batches, and in this case you can't have a map which loads all the elements at once. So you can, if you want to use a map, you can either up till a limit you can just insert it and then go for the next batch, or in the other case you can just sort it and then use the pointers based on the limits. Thank you. If you have any comments for us or a better solution, please leave it down in the comments below. Thank you.